In this video we will do an R exercise using a dataset to estimate a simple linear regression model. So here we have the data problem set here, which tells us to download the wage to Excel file and use two variables, one salary variable wage and IQ score. So the first task is to find the average, so sample average salary and average IQ in the sample, and what is the sample, okay, also the standard deviation of the sample. So let's do A first. I have written an R code here, but I haven't yet imported the data into R. So let's first load the library for read Excel package. Now this package basically allows us to import the data into R that's stored in Excel file. We can type the code here, or simply you can go to import dataset and come to the from Excel, browse. Now locate your data. So that mine is in desktop, so that's wage 2 data here. Now as you can see, the data doesn't have column names, so which means then I have to untick this first row as names, yeah, so that the first row is not used as a name. Instead Excel, sorry, in this case R will sort of assign names here. So for example, this column here is x1 column, this column will be x2, x3, and so on and so forth, yeah, in that sequence, yeah. Otherwise Excel treats the first row as the name, so name containing the names, yeah, so I have to untick that. Now if I needed the code for later use, I would usually copy this. So copy this, let's say this part, yeah. So right click, copy, and put import, yeah. So that's now wage data imported. As you can see, it's right here. Now let me paste this here, yeah, and then I will just give it a name in R data, yeah. That's my data file data. I don't need the view wage 2. I rename it the file name or the dataset name here once it's imported into R. Now this is when your data is in Excel format, yeah. What if your data is in CSV format, yeah? What do? Well, you go to import dataset and you choose from text, reader from text, yeah. Click that. Here you have to just browse to the directory where your data is stored. So in my case it's here, wage 2, open. Right, so as you can see, it now has R imported the data, and this is how it's gonna look like. First row contains names, or basically R is treating the first row of the data set as the name. So I don't want that, so I have to untick here again, yeah, untick that. So let's see what happens. Now I got the names kind of labeled, yeah, properly, yeah. So 17 columns, 17 variables are stored here. It is now possible that some of you will get sort of messy columns. Let's say there are 17 columns, but you may get 3 or 4 columns because maybe you have a different version of, for example, Excel, yeah. Maybe this is geography specific. It looks like continental European sort of a version of Excel or Microsoft Office treats the CSV files slightly differently apparently. The delimiter is not comma for them. I think, if I remember correctly, it was a semicolon, yeah. So if you get such situation where you have not all the columns, yes, shown here, then come here to the delimiter and then choose semicolon and see what happens, yeah. In my case it's the opposite, yeah. It is actually in the English version, so I have to change it to comma, but in a different version you may have to just play around with these options, yeah. Tab delimiter, for example, is another option, yeah. They don't work for me, but if your original imported file shown in this form, then change it to a suitable format, yeah. So I'll change the comma to get the right format. So I will just copy this again. This is a code for future use, for example, yeah. I may want to use it later. In that case I'll just store everything here and kind of automate the importing process, yeah. So this is data as well. Yeah, right, done. So now what I want to do is now, so my data is stored as data in R. Let's just view it. I think I saw view the data in the view form. For some reason it didn't work. Let me just bring it as Excel. Now that I have the data, I can view it now. Yeah, all viewed, but I still have the problem here. These columns are not named, so I need to name them. If I go back to check what needs to be done here, I think it was wage and IQ. So let's go to the description of the file. So my first column, the first column in the data contains the values for wage variable, so this is the first column, and then IQ. Yeah, so this is the third column. Yeah, I need these two scores names. So what I do here is now I simply type the code that what happens is that it extracts the first column from the data set. By the way, one other thing here, cbind basically puts together the variables, yeah, that I would like to put together, for example, in a new data set. Yeah, so I'm binding two variables here. The first one is the column 1, and the second one is the column 3. So this one is a salary or wage variable, and this one is the IQ variable. So I'll combine them together. Yeah, I'll put them together, and I name it this two variable data as wage data. Yeah, so I will now run the code, and I got the wage data stored here, as you can see, and it says two variables only. Yeah, so there are two variables here. Now these variables are not named though, so I need to name them, or I need to give the columns names. Yeah, so I use the call names function. Call names, so call names in brackets wage data, which is the name of this data that I just created. Now I will assign these names to these two columns. So the first column contains this data column, and the second column contains the third data column, yeah, from the original file. So this will be assigned. So this will be assigned a wage, a name, a wage, and this will be assigned a name, IQ. Yeah. So run this. Done. Now let's see what happened. So I can type this. I can type this code and run this code to get the first, I think if I remember, first 6 rows including the names. Yeah. So run. Okay. So first rows. 6 rows are given, and also the names are given. So clearly the R just renamed the columns from x1, x2 to wage and IQ. Yeah. Now I can simply use these names to call the variables, yeah, to extract the variables. Question number 1 now. It says find the average salary and average IQ in the sample. What's the sample standard deviation of IQ? Okay. So, well, because there are only 2 variables and I need to find or calculate both variables standard deviation and mean, I could simply use column means of wage data. Yeah, so I can run that. So these are the mean values for wage and IQ scores, and standard deviation for IQ. Let me have a quick look. Yeah, it's only for IQ. Yeah, so in that case, notice what I am doing here. ST is the function for standard deviation, and wage data is the main variable, and IQ is the variable within this. Sorry, it's just a column name. Yeah, it's also a variable, of course. Wage data is the data set, I should say. Yeah, it's the wage data. It's the data set that contains the 2 variables. So if I use the $, I'm basically telling R to just grab IQ from the wage data set. Yeah, so that's the idea here. So I'll just run this now. Yeah, that's it. So it's with an average standard deviation, I should say, is 15 for IQ score. Yeah. Now question number 2. What does question number 2 say? Estimate a simple regression model where a 1 point increase in dollar amount. Use this model to find the predicted increase in wages for an increase in IQ. So I've typed this one again. So IQ explain most of the variation in wages. Yeah. So I have already typed this here, the code that we need. Right, so what is this code about? So I named the model as reg, and that's equal to LM. LM is linear model. Yeah, it stands for linear model. Is Now modeling the data here, yeah, linear model is modeling the data. So in this case, wage is the dependent variable, tilde. So that's tilde here. So let's leave some space just in case. So tilde IQ. Now here, wage is a function of IQ. Yeah, it's a simple linear regression, and I'm telling R, in this case function LM, to use the variables from the data set called wage data. Yeah, so LM now will use the data set wage data to grab wage column and also IQ column data. Yeah, so these are the names of the variables within the wage data set. So let's give it a space and run the regression. So no red error message, that means R executed the function properly. So click run now for summary. So let's have a look at the summary here. Okay, interesting. So this is the R output, a little messy, isn't it? So we don't need much of this. We'll look at the coefficient estimates here. So this is the estimate, 116.99 for the intercept with associated standard errors, t-values. And this is the IQ scores estimate. Yeah, so it's the partial effect. Yeah, this estimate is the partial effect of IQ on the dependent variable, which is wage. Yeah, so that's the answer here. What it means is basically is that let me just give it a bit of an interpretation here. When the IQ score increases by 1 point, the wage increases by 8.30. Yeah, so it could be $8.30 per hour. Yeah, I don't remember the units of measure for this wage data, but this is the roughly this is the interpretation of this coefficient estimate. Yeah, in a simple linear regression model. Next, we will make a prediction here. If you remember, let me just read it again. It said, use this model to find the predicted increase in wage for an increase in IQ of 15 points. So if the IQ increases by 15 points, what is the wage? Well, we have the coefficient estimate here, times it by 15. That gives us the change in wage. Yeah, so $1 point change in IQ will lead to that much of change in wages. So now if the IQ score increases by 15, then times this rate 8.30, which is the which is taken from here, yeah, by the change in the score. Yeah, so run here, run, and we just run this one more time. Yeah, that's 124.5 change in wages. Yeah, that's the answer to question number 2. Now C. Now estimate a model where each 1 point increase in IQ has the same percentage effect on wage. So this is now, as you can see, unit increase or point increase converted into percentage effect. Yeah, percentage effect. So if IQ increases by 15 points, what is the approximate percentage increase in predicted wage? That's an interesting one. Now here we have to carefully rewrite the model as a log lean model. Yeah, log lean. So unit increase is going to transform into percentage increase. So let me just give it space here to make it clear. So again, I just let me call this let's say this is reg 1 now. Yeah, maybe log reg. Yeah, log reg. It's so that we don't overwrite the original reg result. Yeah, so original model was reg. If I don't rename this regression model, R will overwrite this result. Yeah, with the new one. So here this is a log lean model. So LM, again, LM is the linear model function. So LM in brackets logarithm of wages. So that's our dependent variable. Then IQ in levels. Yeah, whatever the points are, the units of measure is doesn't change here. Then again, data has the data set name here, wage data, which is our original wage data that we created earlier. So now let's run it, and as you can see, no problem. So let's run the summary. Now the interpretation will change. Of course, the coefficient estimate also will change. As you can see, intercept will also change. And interestingly, this to become also statistically significant compared to this one here. Only IQ's estimate was statistically significant, but here both of them are statistically significant. We will discuss this in more details later. So it looks like this is our, what we call this, coefficient estimate for IQ. This is the partial effect of IQ on the log wage. Now when we interpret this, we say that a 1 point increase in IQ will result in 0.88% increase in wages. The reason it's 0.88 is that we convert the point increase to percentage because there's a log dependent variable, yeah, log wage, yeah. So we convert the point increase into a percentage by multiplying this by 100, yeah. So that gives us a percentage increase in wages, yeah. So that's the interpretation. Now there was a second part of the question. If IQ increases by 15 points, what is the approximate percentage increase in predicted wage? Now to do that, I'll use this calculation, yeah. So delta wage, a change in wage, this is my notation for change in wage, yeah. So delta wage is equal to the coefficient estimate from here, that's this here. So maybe I'll just copy all of it to get an accurate estimate, let's say, yeah, precise estimate, times the 15, which is the change in IQ, then brackets times 100, yeah. This 100 converts the result into percentages, yeah, because we have log wage here. If this wasn't a log wage, it would simply be just without the 100, yeah, multiplication, yeah. So let's run this and let's run delta. So that's the percentage increase in wage when IQ increases by 15 points. So those people who have 15 points higher IQ scores will earn 13% more